For years, using AI meant rendering somebody else's computer, sending it your data, and watching a meter run every time your application made a request. That is no longer the only serious option. Today, a complete AI stack can run on hardware you control. You can download the model, give it a private interface, connect it to a coding agent, serve it to a team, route traffic between providers, build visual workflows, and even fine tune the model for your own work. What works is a small set of focus tools with a clean connections between them. One giant application that promises to do everything usually creates different set of problems. There are 7 open source AI tools that make that possible now. These tools are meant to be connected. Their order matters less than the job each one handles. Ollama runs models, OpenWebUI gives them a friendly interface, OpenCode turns models into a coding agent. vLLM serves them efficiently at production scale. LiteLLM puts one gateway in front of every provider. ComfyUI turns generative media into a repeatable graphs. And Unsloth lets you customize open models instead of accepting the default behavior forever. You do not need to install all 7 this weekend, but you can start with one which is actually the bottleneck. So the first tool is Ollama, and it is still the simplest front door into local AI. The basic experience is almost suspiciously easy. Install Ollama, run one command with the model you want, and the runtime handles the download and the configuration and local inference process as well. Instead of creating an account and copying an API key, you get an endpoint on your own machine. That endpoint is what makes Ollama more than a chat application. A developer can connect a Python script, a JavaScript application, an editor extension, and another tool in this video to the same model. The model can change without forcing every application to change with it. Ollama now supports a wide range of current open models and exposes a straightforward REST API. It is especially useful for development, private document experiments, prototypes, and any workflow where sending data to an outside provider is unnecessary or undesirable. The catch is hardware. Running locally does not make the compute free. Model speed and quality still depend on your memory, processor, GPU, quantization, and context length. A small laptop is not secretly a data center, but Ollama removes enough setup friction that you can discover what your machine can actually do in minutes. If you install only one tool from this list, this is the logical place to begin. You can actually experiment with it, you can understand how long it takes to respond, and then you can also check how intelligent a particular model is. The second tool is that what is the interface which you can use on it. So OpenWebUI provides that missing interface. It is a self-hosted AI workspace that can connect to Ollama and to OpenAI compatible agents. OpenAI compatible endpoints, I meant. The result feels familiar to anyone who has used a modern hosted chatbot, but the deployment and data path can remain under your control. Chat is the first thing you see. The team features are where when OpenWebUI gets more useful. You can organize models, save prompts, attach documents, create knowledge collections, and give users one consistent interface even when the model behind it actually changes. Its retrieval features also make it practical for internal documentation. Instead of pasting the same background into every conversation, you can create a knowledge base and let the interface retrieve relevant material when it is needed. OpenWebUI can operate offline, but you still need to think about authentication, backups, permissions, and the license requirements of the version you deploy. Self-hosting moves responsibility, it does not actually eliminate it. OpenWebUI is the next ideal step when a command line is no longer enough and a private model needs to become a usable product for you, a client, or even a team. So the ideal step would be after installing Ollama, connect it with OpenWebUI so you have a proper chat interface for you. And the third tool is OpenCode, an open source coding agent built around the terminal. Traditional code completion predicts the next few lines. An agent works at a larger scale. It can inspect a repository, understand a task, propose a plan, edit multiple files, run commands, read errors, and continue until the change is complete. OpenCode is interesting because it does not lock that workflow to one model provider or one proprietary editor. You can connect supported hosted models when you need maximum capability or connect a local endpoint when privacy and control matter more. The terminal first design is also a strength. The agent works beside the same version control tools, test, build commands, and project files that developers already use. It is not pretending that software development happens in an isolated chat box. Do not confuse autonomy with correctness. A coding agent can make a bad architectural choice much faster than a human can type one. Give it like focus task, make it explain the plan, keep tests close and review the diff before shipping. Used with those boundaries, OpenCode becomes a force multiplier, not a replacement for engineering judgment, but a fast operator for the repetitive work surrounding that judgment. Ollama is excellent for getting a model running. vLLM is what you reach for when one local experiment becomes a production service with many simultaneous users. The project focuses on high throughput, memory efficient inference. In plain language, it tries to keep expensive accelerators busy and serve more requests from the same hardware. vLLM manages the model's key value cache or KV cache, the memory used to keep track of tokens during generation. It also supports continuous batching, so incoming requests can share work instead of forcing the server to process every user in isolation. vLLM exposes an OpenAI compatible API. Applications written for that familiar API shape can often point to a vLLM deployment without a complete rewrite. This makes it easier to test an open model behind an existing product. This is not the first tool to install on a low memory laptop. vLLM makes the most sense on dedicated GPU infrastructure rather than on your laptop because where concurrency, latency, memory utilization, and operational reliability justify the additional setup because we are going to GPU infrastructure. Choose it when the question changes from can this model answer to can this model answer hundreds of people efficiently, predictably, and without wasting the hardware. So vLLM can help you when you are ready to go production. The next tool is LiteLLM. So once an application uses several models, a new kind of complexity will appear. Like most of the time it is the case. Every provider has different model names, authentication, rate limits, error formats, pricing, and a fallback behavior. If that logic spreads across your application, changing providers becomes risky and expensive. LiteLLM solves this by acting as a shared SDK or proxy in front of many model APIs. Your application talks to one consistent interface. LiteLLM translates the request, track usage, and sends it to the provider or local endpoint you have selected. Because traffic passes through one place, LiteLLM can enforce budgets, issue keys for each team, retry failures, balance load, and apply guardrails. A production team can route simple tasks to a cheaper model, reserve a stronger model for difficult work, and fail over when a provider is unavailable. The gateway also gives you leverage. Model vendors will change, prices will change. The best model for coding may not be the best model for extraction or image understanding. A clean routing layer prevents these decisions from leaking into every feature. LiteLLM is in the path of every request, so treat the gateway as critical infrastructure. Secure it, monitor it, and avoid logging sensitive prompts without a clear retention policy. LiteLLM becomes useful once model choice needs to be a configuration decision instead of an application rewrite. The next tool is ComfyUI. ComfyUI approaches generative media as a graph instead of magic text box. Each node performs a specific operation: loading a model, encoding a prompt, applying a control image, sampling, decoding, upscaling, or even saving the result. Connections show exactly how data moves through the workflow. Serious creative work rarely consists of one single prompt followed by one perfect image. The working pipeline includes models, adapters, masks, reference images, seeds, and post-processing. A visible graph makes the process inspectable and repeatable. ComfyUI now reaches beyond still images into video, audio, and 3D workflows. A finished graph can also be saved and invoked through an API. A designer builds the workflow visually while a production system supplies new inputs and queue jobs automatically. The ecosystem is powerful, but custom nodes require discipline. An unknown node is code running on your machine. So you have to pin versions, review what you install, and keep production workflows reproducible. ComfyUI fits jobs where creative control matters more than one-click simplicity. It is particularly good when the same visual process must run repeatedly for different products, scenes, or clients. The last tool is Unsloth. Unsloth because sometimes changing the prompt is not enough. You need to change the model. Fine-tuning adapts an existing open model to a task, style, domain, or even response format. The traditional problem is cost. Training can consume large amounts of accelerator, memory, and time. So Unsloth focuses on making that process faster and more memory efficient through optimized kernels and practical training workflows. It supports techniques such as LoRa, where you train relatively small adaptive weights instead of rewriting every parameter in the base model. These optimizations allow useful experiments on smaller hardware. You can teach a model a structured output format, improve behavior on domain examples, or create an adapter for a specialized workflow. The project also provides a local studio interface for training and running supported open models. Fine-tuning is not a cure for weak data. A small collection of inconsistent examples can make a model confidently worse. Start with an evaluation set, keep a clean holdout, and compare the adapted model against the original and document the exact base and training configuration. Unsloth comes later after prompts, retrieval, and tools have reached their limit. Start only when you can measure what better means. Now put the layers together. Ollama runs a private model for development. OpenWebGUI gives people a clean way to use it. OpenCode connects to model to software work. When demand grows, vLLM serves models efficiently on dedicated infrastructure. LiteLLM becomes the front door that routes each request to the right local or hosted endpoint. ComfyUI handles repeatable media generation. Unsloth produces adapters that make selected models better at your specific task. These tools do not need to live on one single computer. The value is the boundary between them. Standard APIs, replaceable components, and data paths you can understand. So if you want private chat, begin with Ollama and WebUI. If you want an engineering agent, add OpenCode. If you are serving many users, evaluate vLLM. If multiple providers are creating a mess, place LiteLLM in front of them. If the output is visual, build the workflow with ComfyUI. And if a model consistently fails a measurable domain task, prepare a careful Unsloth experiment. Start with one working path, measure it, then add the next component. So I hope this whole stack will help you understand how you can set up your own AI stack so that you can build your own things. Let me know if you have any questions on this, or if you want to know specifically about one single section, let me know in the comments.